Assalamu alaikum dear students. This is paper 9702, paper 1, October November 2004, and we are trying to solve questions from 1 to 13. Actually, we have already learned the theory of these questions, therefore we are just limiting ourselves up to question number 13. This is question number 1. Which line of table gives values that are equal to a times of PS 1 picosecond and a distance of 1 gm 1 gigameter? So this is basically based on our knowledge, and we know that when we are talking about the pico, this is basically 10 to the power minus 12, and when we will talk about the giga, then it is 10 to the power 9. So these are the prefixes we have to remember. A picosecond 10 to the power minus 12, and here we have the gigameter, which is 10 to the power 9, and simply you can say that the answer is C. Of course, the others are not correct. This is here you have nano, here you have pico. So nanos, of course, are not correct in the first you can say option, and first two options. Then in C we have 10 to the power minus 12, which is pico. D is also 10 to the power minus 12, but you know that here you have the other part as well. So 10 to the power 9 is basically giving you giga, and this is not the 10 to the power 12 is not the correct answer here. So this is what we have. Simple answer is C. So remember these things, and these are the questions based on our direct knowledge, you can say, or remembering. Question 2. Which of the following definitions is correct and uses only quantities rather than units? Yani here, like we have density is mass per cubic meter. So here we have the density, which is of course the quantity, but the definition is giving in terms of mass and meter cube. So this is your quantity, and here you have unit. So it's not required. Both must be quantities. So here A is not the right option. Then potential difference, of course, the quantity. Again, quantity is energy per unit current. The energy per unit current. Energy per unit current, here both of these are quantities, but when you will write the potential difference, you should know that it is energy per unit charge, not per unit current. So that's why this option is not right. This you can say condition that only quantities we are talking about, or taking the definition in terms of quantities only, is fine here, but the definition is not correct. It's not energy per unit current, but it is energy per unit charge. So be careful. Then in C, pressure is force per unit area. So of course this is the third quantity here. Force is a quantity here, and area is also a quantity. So you know that pressure is equal to force per unit area. So this is our correct answer, because both the terms we are using are quantities, and of course we have the correct definition as well. As far as D is concerned, speed of course is a quantity, but here you know that distance is a quantity. Per travel per second, so this is your unit. So again the condition is not being followed, so this is not the correct option as well. So be careful of these things, that which part is our, or which choice is our correct answer, and fulfilling all the requirements, you can say. This is very important. Then in question 3, when a beam of light is incident on a surface, it delivers energy to the surface. The intensity of the beam is defined. This is the definition of the intensity of light, or intensity of beam. And what is the definition? This is the definition. The energy delivered per unit area per unit time. What is the unit of intensity expressed in SI base units? So first of all, what we can say, what we can do, that intensity is nothing but energy per unit area per unit time. This is the equation we can write according to the definition given. And of course, as we are talking about the SI base units, so here you know that energy is joule. Here you have meter square, then you have time second, but you know that joule is not the base unit, so what you can write, kg meter per second square, this is force, multiply by the distance, so this will give you the complete unit of energy, and here you have meter square second. So now we are talking about the unit of I. This is unit of intensity. So what you can say, what we can write, meter squares will cancel out, and here when this second will move to or as the numerator, then what you can write, kg per second cube, kg per second cube. So be careful, and this is the option D which is correct in this case, and here you have of course other options not correct. And if you want to see the details of these you can say topics, or you can say the units and all these base units and all these things, so you have to go to my lecture number 1 of this channel, and you can learn the details of this topic. If you are new on this channel, you can subscribe this channel, and of course you have to press the bell icon as well. Share and like if you are getting something out of it, and I think this will be a beneficial you can say a situation for you, so you can learn number of things here. Question number 4. The deflection of the needle of an ammeter varies with the current passing through the ammeter excuse me, as shown in the graph. So what you can say, what is happening in this case, deflection of the needle, of the ammeter needle, you can say. Here you can see that the values are increasing but with decreasing order, yani gradient is continuously decreasing. So the situation is that the values are increasing but with decreasing order. So where you can see this situation, like here in case of B, the values are increasing with increasing order, yani each gap is increasing. This gap, when you will check these gaps, then you will see that they are increasing with time. So this is not our situation. So simply you can say that this is not the correct option. Then here you do not have any you can say even situation. First you have the decrease, and then again you have increase, so this is also a not correct option. Here again you can see the situation is different, and what is happening, the increase then decrease again. So this is not again the correct option. What we want, we have a situation that the values are increasing with decreasing order, so here you can say and see that the gaps between these values are decreasing with increase values, and in between 0 and 1 you have a big gap, then 1 to 2 you have a little smaller than the gap, as you have you can say between 0 and 1, and so on. So the gaps are decreasing, showing you that the gradient over here is decreasing, and therefore simply the option A will be your correct option. Hope you are getting what I am saying. This is very important, that you have to check that what is the trend of the graph. So the deflection shows that, or the graph shows that the deflection is increasing with time, or current in this case, of course, not time. So the current is increasing, the deflection is increasing as well, but with decreasing rate. And this is the situation which we have according to our graph. So this is something which is the correct option in our case. Then here you have question number 5 rather. When a 12 volt 50 hertz supply is connected to the Y terminals of the oscilloscope, the trace in the diagram is obtained. Basically this is something related with the oscilloscope, and here you have set the Y terminal and this is the values given. So what they are saying, when a 12 volt, so 12 volt 50 hertz. So remember this thing that the values you can say the getting is 12 volt and 50 hertz. 12 volt is basically the amplitude of this graph, or you can say from the amplitude of this graph we will get the value of this thing. As far as the 50 is concerned, this is something which is frequency, and along the x-axis you will have your time. So when you will get the time, then you will get the frequency ultimately. What is the setting of the time based control? So here what you have to check that what is the value of frequency? 50 hertz. So this is the first information you have. This is F, 50 hertz. Then you need to know that if you have 50 hertz, that what will be the value of the time period. So for this you know that time period is equal to reciprocal of frequency, or 1 over F. And when you will use this value 1 over 50, you will get the value 0.02 second. Now you have to check that this wave form is between 8 small boxes. 8 small boxes. So simply you can say that if you have 0.02 second as the time period and you want to know the scale, which is basically the time based setting or time based control, so basically you are going to find out the scale. So what is the situation here? 8 centimeter you have for the complete wave. So 1 2 3 4 5 6 7 8. So what will be the value for one a box or 1 centimeter? So of course what you are doing, you are dividing the time period by 8 centimeter, and the value which you are getting is 2.5 into 10 to the power minus 3, or simply you can say that it is nothing but 2.5. This is nothing but millisecond. So this is the scale here that you are saying that it is 2.5 millisecond per centimeter. If you will have this scale 2.5 millisecond per centimeter, then you will have this shape which is given. Basically this shape is given, and here you have the complete you can say wave from point say A, B, C. So from point A to C you will have a complete wave, and with the help of this information or this diagram you are getting the information that the time base is nothing but 2.5 millisecond per centimeter. The rest of the options are of course not right, not correct. So be careful. Then in question 6 rather, 4 students each made a series of measurements of acceleration of free fall g. The table shows the result obtained. Which student obtained a set of results that could be described as precise but not accurate. Precise but not accurate. So first of all, in my lecture number 4 and 5, I have explained in detail the precision and accuracy. So if you want to learn this precision and accuracy in detail, you have to go to lecture number 4 and 5. Lecture number 4 and 5. Here you will find the details of these precisions and accuracy, but here we are just giving you the brief sort of information, and this is nothing but not close to actual value not close to actual value. This is the thing that not accurate. But what you can say, but all values are close to each other. If you will have this situation, then you can say that you will have a reading which is or measurement which is precise but not accurate. Yani if you have a target and you are not achieving that target, but all your you can say values are close to each other, then you can say that you have a precise reading, a precise measurement. And here in the given table you can see that the value of G, as you know, is 9.8 meter per second square. So where you have this situation that value is not 9.8, so simply you can say that D is the option where we do not have any 9.8 here, but they are close to each other. But they are close to each other. So C, B, A, all these are not correct. But here what you can say, like in case of A 9.81, 9.84, 9.83. So you can say that this is the situation where we have precise and accurate reading, because here values are not only close to 9.8 but also close to each other as well. So this is situation like more precise, more accurate, but what they are asking, precise but not accurate. So what we have to check, that these values or values given must be close to each other but not close to the actual value, which is 9.8. So our option D will be the option for this case. And of course the question number 6 we have solved in this way. The knowledge of precision and accuracy is required. Then in question number 7 you have the situation of the projectile motion. Again, you can go to the lecture if you want to learn in detail the lecture on, of course, projectile motion. I have already delivered, and you can see on my channel. In the absence of the air, this is the basic condition for the projectile motion. In the absence of the air resistance, a stone is thrown from P and follows a parabolic path in which the highest point, highest reached is T. The stone reaches point Q just before landing. So this is the information they have given. The vertical component of acceleration of the stone is vertical component of the acceleration. So this is very, very important. In this case, remember one thing, that the motion is basically under gravity. So throughout this motion you can say that the acceleration will be acceleration due to gravity. So simply you can say that each and every point we will have same value for vertical component of acceleration, which is nothing but G. So it's not 0 at T is not correct, greatest at T is not correct, greatest at Q is not correct. Only D is the correct option, which says that the same at Q as at T. So whether you are at Q or T or any point somewhere in between, the value of the vertical component of acceleration, which is the G value, will remain the same. So this is what we have to learn here. So what is the situation? Acceleration G is always constant throughout the projectile motion. Remember this point. Even I can write here, G is always constant throughout the projectile motion. This is the bottom line of information for this question. Then in question number 8, we have a situation when a car driver sees a hazard ahead. She applies the brakes as soon as she can and brings the car at rest. The graph shows how the speed v of the car varies with the time t after the hazard is seen. Which graph represents the variation the time t of the distance traveled by the car after the hazard has been seen? So this is the basic situation here, that the question says that what is the situation here? The body is moving with uniform velocity. Then of course between point or time t1 to t2, you can see that the value of the velocity decreases and becomes zero. But as the gradient over here is constant, so this is one thing. But as far as the decrease is concerned, this is a uniform decrease as well. So this is something which is important in this case. Here what you can say and see between time t1 and t2, they are saying that the distance is constant. If the distance is constant, then there will not be any decrease or increase in the velocity. As we can see here that between time t1 and t2, the velocity is decreasing. So option A is not correct, because you know that for the distance time graph dt or st, you can write the gradient is velocity or speed. Okay, for dt graph or st graph, the gradient is velocity. So this is something which is not correct. Why? Because there is zero gradient, but here we have velocity between time t1 and t2 decreasing. Velocity is decreasing, so this is important. So that's why A is not correct. Similarly, you can say and see that in case of B, you can see that we have two constant velocities, yani between t1 and t2, particularly if you will consider the gradient is same, constant, slope is constant, so the velocity is constant. But what we can see here, the velocity, yani in this graph, velocity is decreasing. But this graph shows that between time t1 and t2, the velocity is constant, which is not the case. Here in C, between time t1 and t2 particularly, you can see that the slope is decreasing, then the distance is increasing, but the slope of this graph is decreasing, or the gradient of this graph is decreasing. So it means that gradient is nothing but velocity. So what we can simply say that this graph shows that the velocity is decreasing with the passage of time. So this will be our correct option. And here when you will go for D, is just opposite, yani the velocity is increasing with passage of time because the gradient is increasing. And as you know that the velocity is decreasing in this case, so D will not be the correct option. What did I say? The gradient is increasing, then the velocity is increasing in this case, but in our case velocity is decreasing. So be careful. And this is basically something which we have learned again in our theory lecture in detail. So if you want to go for the theory, you have to follow that particular lecture from my YouTube channel. So this is something which is question number 8, relation between the distance time graph and velocity time graph. Then here we have another question, question 9. An object falls 10 meter from rest, 10.0 meter from rest before entering some water. Assuming negligible resistance, what is the time taken to reach the water and the speed with which the object reaches the water? So two things are required. First of all, what they are saying, the object falls from rest, so you can say u is equal to 0 before entering some water. So what is happening in this case? You have to know the you can say time and speed. So what you can write here, that h is equal to ut plus half gt square. This is the second equation of motion. S is equal to ut plus half at square. And for vertical motion, we can write this equation in this way, that h is equal to ut plus half gt square as The initial velocity is 0 in this case and height is 10. So simply you can say 10 is equal to half into g value is 9.8, t is square. So t you can calculate, and of course very easily you can get the value, and the value which you will get is 1.43. For this t you are getting the value 1.43. You can do the calculation yourself as well. And here when you will use this t, so first of all what we can do, we can reject these two options because these are two correct options for the time. But here again this is something which is millisecond, so be careful. This is what we have here, this is millisecond, yani 1.43 will come as this way, yani 1.4 millisecond. So this is 1.4 millisecond, here 143 millisecond. Now as far as the speed is concerned, what we can do, we can use this value here, that v is equal to u plus at, the first equation. So v is equal to gt in this case. So simply you can say that v is nothing but 9.81 into 1.43 millisecond, and this will give you the answer as 14. So this is the 14. So this is what we have as far as the value is concerned. 14 is the value here. This is the velocity required or speed required, and this is the value 1.43. So simple thing is that option C is also not right, because 10 is not the correct part, but D is the correct, because both these, any time and your speed, are incorrect values. So this is what we have as far as the question 9 is concerned. Okay, so this is something which we have to consider here. Okay, then go to question number 10. A constant mass undergoes uniform acceleration. Uniform acceleration. Which of the following is a correct statement about the resultant force acting on the mass? So remember this thing, that for uniform acceleration we need force, but of course constant force. So it increases uniformly with respect to time is not correct. It is constant but not zero. I think we have done this part or this question before as well. So this is the situation here. The force must be constant but not zero. So be careful. Of course, the other options are not correct. It is proportional to the displacement. It is proportional to the velocity. Both these are not correct options. The only thing which is required for uniform acceleration is constant force, but constant doesn't mean zero. So be careful. Here we have question number 11. A particle of mass m strikes a vertical rigid wall perpendicularly from the left with velocity v. If the collision, what is happening? The ball is coming in this direction. If the collision is perfectly elastic, the total change in the momentum of the particle that occurs as a result of the collision is. So what is happening? The ball or the particle will strike, collide, and rebounds. So what is the situation of the change of momentum? So simply we can say mv minus mv, because the velocity after the collision will change the direction with the same value. But the thing is that, as I said, the situation is only correct for your elastically or elastic collision, perfectly elastic collision. You have this situation that there will be no loss or change in the value of the velocity. So the change in momentum you want to write in this way, or even del p, you can simply say that it is mv plus mv. So 2mv is the right situation, and of course the direction will be towards which direction? Towards left. So be careful. So it means that simple thing is B will be our correct option. These options are not correct. In option 2 you can say that 2mv we have, but the direction is not right. And be careful that momentum is momentum is a vector quantity. So be careful when you are going to calculate the change of the momentum. You have to consider the direction as well. So be careful of this situation. Now we have another question, which is question number 12, based on forces in equilibrium. Which two vector diagrams represent the forces in equilibrium? Again, the same thing. You can go to my lecture on forces. You can go to the lecture and lecture, of course, theory lecture in detail on my channel. But main point over here is that whenever you will see forces in equilibrium, you have to consider the triangle, which is a closed triangle. Closed triangle. You have to consider a closed triangle for this situation. When the forces will be in equilibrium, you can represent forces with the help of a closed triangle. And what does this mean, closed triangle? So you can see here that here you have this situation, that this triangle is not closed, means you have this vector as a you can say the resultant vector. So this is not a closed triangle. Similarly, you have to check the other one, like here you have this thing or this thing. So you can say that this will be the situation, and over here this will be our resultant. So this is not a closed triangle, so we cannot you can say use the triangle Q for this forces in equilibrium situation. As far as your R is concerned, if you will start from suppose this side, you can see that it is giving you a closed triangle. A closed triangle means that you can start from one point and you will come back to the same point without any resultant force. So this will be a situation. R is a triangle which is representing forces in equilibrium. Similarly, if you will go for the triangle S, what will be the situation? You can see that you have a closed triangle. So again, the same thing, you can say that this triangle is also the right triangle for the forces in equilibrium. So this will be again a better correct option, you can say. So which two vector diagrams? So simply you can say that R and S, and this is nothing but option C. R, S, N are the triangles representing your forces in equilibrium, because they are closed triangles and do not have any resultant force. So if you will have any resultant force, of course the body will not be in equilibrium. Again, you have to go for the detailed discussion or theory, and if you want to learn the theory of this topic, you have to go to my lecture based on this topic, forces in equilibrium. Question number 13, a long uniform beam. Here you have a long uniform beam is pivoted at one end. A force of 300 Newton is applied to hold the beam horizontally. So this is something which we are applying here. This is the force which is upward force and trying to balance this uniform beam. There are 2 points to remember, that whenever you will have a uniform beam, the weight of the beam will act at the center of the beam, yani geometrical center will be the center of gravity or center of mass in this case. So the pivot over here, so what you can say, the weight of the beam is somewhere here at a distance of what? From the pivot, we have to consider only this distance for WB, and for weight, of course, the perpendicular distance will be this one. So be careful. This is something which is given, it is 2.5, but for weight, as you can say and see, that the total length is 3, and 2.5 plus 0.5, 3 meters. So simple thing is that over here you will have a force which is nothing but 1.5 1.5. So simply what you can write, that the weight of the beam multiply by 1.5. What is the situation here? You can say and see that this is something which is giving you the weight of the beam is trying to rotate the body clockwise. So you can write here that the clockwise moment is equal to anti-clockwise moment, which is basically principle of moment. So you can see here that this 300 force of 300 is trying to rotate the body anti-clockwise, and what is the value here? This is 2.5. So what they are asking for, weight of the beam. So simple thing is that what you will do, weight of the beam is nothing but 300 into 2.5 divided by 1.5, and the answer which you will get is simply, you can calculate, which is nothing but 480. 480. When you will calculate this thing, you will get 480. So this is something which is a simple calculation, so you need not to go for other options, and here you have the simple calculations, so you are getting this value. This question number 4 is basically not included in this syllabus, so I'm just stopping here this discussion. And of course, if you are new on my channel, so you have to subscribe the channel to get all the uploaded lectures. Of course, I am uploading the past papers as well as the theory lectures, so I think you can get a lot of it, and from this channel, of course, you can learn number of things. So as I said, that if you are learning something from this channel, then you have to share this channel as well with your friends and colleagues, and do hard work. Of course, there are very few months left for your exam, so be serious and take it seriously. Inshallah, see you in the next lecture. Till then, Allah Hafiz, take care.